right, boys and girls, let's take a look at our first free response question. It's a calculator problem. We're given a table of values and a good old particle problem. So a particle moves along a straight line and its velocity in inches per second at various times in seconds is given by this table below. So the table on the left, not really consistent on what it goes up by. It goes up by 2, goes up by 3, goes up by 3, goes up by 2. Over here we're just given a bunch of ugly numbers, which is why it is a calculator problem. And so, here we are. We'll do A and B, and then C and D. We'll go back and forth between here and the calculator. But let's get started. Estimate V prime of 9. Now, V prime of 9 means if you were to take the derivative and plug in 9, what do you get? Well, this is the regular old function, and there is no 9. So what I'm thinking is, okay, the derivative. Oh, so the derivative means slope. So if I'm going to estimate V prime of 9, why don't I estimate the slope between 8 and 10? Because 9 just so happens to be in the middle of that. So what we're going to do for part A is we're going to do V prime of 9 is going to be the slope formula connecting 8 and 10. So we'll do V of 10 minus V of 8, vegetable juice, over 10 minus 8. So we'll run to our calculator and find out what V of 10, let me see, V of 10 is 12.100 minus V of 8, which is 7.744 over 10 minus 8. We'll just throw all of that into a calculator, get some number, and we'll see what happens when we do just that. All right, let's plug stuff in. Big parentheses for the numerator, 12.100, which is just 12.1. Minus 7.744, so 7.744, close the parentheses, all divided by 10 minus 8. It's going to be 2, but we're just going to use our calculator anyway for just, showing you how to do stuff purposes. Hit enter, and you get, a nice 2.178, nothing to really round. So let's go back, write that out, and explain what that means in this context. Okay, so we ended up getting 2.178. Now, if we're given a particle moving at inches per second over time, right, the derivative of that is going to be inches per second squared. So the answer for A is going to be inches per second squared. Okay, and that's because it's the acceleration. When you take the derivative of the velocity, you're going to get acceleration. That's why we get the per second squared attachment. Now that's A. B is asking us to describe what the integral of V prime of t from 0 to 10 represents. The integral, right, between 0 and 10 of V prime of t. So I guess we'll do dt. Now what that gives us normally is we would say, okay, so that would just be like the capital V of 10 minus the capital V. But what that means here is if we're taking the integral of the derivative, we kind of go back to square one, which in this case is regular V of t. So this is going to end up being V of 10 minus V of 0. Right? And I don't need a calculator for this one. We already know V of 10 is 12.100, V of 0 is 0, and because I kind of can do the math in my head, I know I'm going to get 12.100. And since this is dealing with the original velocity, it's going to be inches per second. Okay? So the answer to A was acceleration. The answer to B was take the acceleration, integrate that, which takes you back to the original velocity. Fun, fun, fun in the sun. Now what we're going to do is we'll open up a new slide, okay, and we'll take a look at C and D on this slide and try to understand what they mean and see if we need our calculator for that. So C is asking us to use Riemann sums. Ooh, everybody loves that, with 4 subintervals to estimate the total distance traveled by the particle in the first 10 seconds. Left Riemann sums. Ugh. Okay, so the way you handle left Riemann sums is we're going to have 4 subintervals. Here we see like 5 chunks, which is kind of what we want because 4 subintervals means U to U, U to U, U to U, and U to U. So what we do is we take the length of the chunks, right? And we use this number because it's considered the left subinterval, right? We could draw ourselves a line, and I don't know what this picture is going to look like, so I'm not going to really lose a whole lot of sleep over it. But again, when you're using left Riemann sums, you're going to use whatever intervals you have and plug in the lower version of that. If it was the right Riemann sum, we plug in the upper version of it, and if it was mid-point Riemann sums, then we would just do the middle. That's not what we're dealing with here. So this interval is 2 minus 0, so we're doing problem C here. 2 minus 0, which is 2 units in length, and we're going to multiply the left side of it, which is going to be 0, plus the second interval is 5 minus 2, which is 3 units in length, and we're going to multiply the left side of it, which is 0.484. So we will want our calculator for this guy. The next interval is going to be 8 minus 5 units in length, so plus 3 parentheses. And we're going to multiply the left of it, so 3.025. And then the next one is 2 units in length, and we're going to multiply the left side of that, 7.744. So let's run to our calculator and see what happens when we type all of that in. Okay, 2 times 0, probably don't need to use that, but I did it anyway. The next one was 3 times 484, so 0.484, easy to memorize, that's a Pottstown area code from where I'm from, plus 3 times parentheses 3.025, and then the next one was 2 parentheses 7.744. It's going to be an underestimate. Oh, ooh, that was a close one. 7.744. Okay. Looks like no mistakes made. Thank goodness. 26.015. So let's go back, write that out, and try to explain what that means. All right, so the number we ended up with, 26.015, and since we're integrating the velocity function, the integral of the velocity function is the position function. So according to this, what this is telling us is we traveled a distance of 26.015 inches. Now, is that realistic? Is that really what's going to happen? No, because if we're using left Riemann sums, then we're probably underestimating our actual answer, but that's what we were asked to do here, and so that's what we did. Now D is asking us to use quadratic regression to find the equation of V of t. So we're going to take this table right here. We're going to do quad reg in our TI-84 plus, and that will get us a formula. Once we get the formula, use the equation to find the actual distance traveled by the particle over the first 10 seconds. Show all the steps necessary. So not only are we writing out a formula, we're going to use that formula to find the actual distance traveled over the first 10 seconds. So here we go. Okay, this is how we do quadratic regression. So we're going to take the table, okay, and we're going to use all the numbers in the table. Go to Stat, go to Edit, and on the left side, type out the x, or in our case, the t values. So that was the left side of the table, 0, 2, 5, 8, 10. Okay? So let's move to the right, and we'll put in those numbers, which was 0 again, 0.484, 3.025, 7 that's a 1, 7.744, and 12.100, which is just going to be 12.1. So in this problem, right, if you remember, we were not just said, let's find the equation. We were asked to find the equation and then use that equation to do something else. Okay, so when we find, quad reg, this is what we're going to do. Go to Stat, go to Calc, and quad reg is number 5. So you can either hit 5 or go down to it. Great. Now, since we're not only going to write out this formula, we're also going to use this formula. We're going to store this in our calculator, so when we use the formula, it's going to be there waiting for us. So store reg EQ, hit enter. Oh, nope, I'm sorry. Go to vars, yvars, enter, enter. Okay, go to vars, yvars, enter, enter. And this will store our equation into y equals. Go down to calculate, hit enter, and there's our equation. It's actually really pleasant. And what we'll do is we'll hold on to it, we'll save it, and then we'll write it down so we don't have to go back and then come back and then go back and then come back. So the equation in this case is just going to be y equals 0.121x squared. That's it. Now, here it is waiting for us when we hit y equals. Now, is it exact? No, because TI likes to always make it different. But part 2 of this was asking for us to find the distance traveled for the first 10 seconds. So we're going to use our calculator to do this. Now, this is our velocity function. This is the velocity answer that we got. So in order to find the total distance traveled for the first 10 seconds, we're going to integrate. So we do that by using our calculator and hitting second trace, which takes us to calc. 7 is the integral. So go down to 7, you get a nice little parabola, which makes sense, and we're going to set our lower limit, since we're doing the first 10 seconds, our lower limit will be between 0, and our upper limit will be 10, and that's going to give us an answer of 40.33333333333333. So let's go back, let's write down all the information that we came up with, and try to explain what all of that means. All right, so let's finish this guy out. All right, we're on D, and the equation that we ended up with was, if we're doing the velocity function, quad reg gave us v of t equals 0.121 t squared plus 0t plus 0, so this is part 1 of that problem. Okay, that's the equation that we came up with. Now, in order to use that to find the actual distance traveled using our calculator, we decided that we would integrate that velocity function, which gives us distance. So between 0 and 10 of the velocity function, dt, ended up giving us 40.33333, which means we actually traveled a distance of 40.3 repeating inches. Now, what we had up here was a complete underestimate, which usually happens, not always, but usually happens with left ream in some intervals, because you're not looking for perfection, you're looking for drawing rectangles and blah, 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 blah. But this is the actual distance traveled according to this information. And this is the underestimate. So yeah, that's part 1, or problem 1 of our free response question here in the ultimate GOAT, whatever I'm calling this thing. So more to come. 4 of them, 5 of them. Ugh. Thanks for watching, like and subscribe. Okay, free response question numero dos. We have ourselves calculator stuff, and as you can see from here, and if you're looking ahead, you're going to be like, yeah, I'm going to need a calculator for this one. You are. Let R be the region bounded by the first quadrant. So let's kind of draw ourselves a picture, because I know what's going to happen, especially since I created this problem. The curves f of x, also the first quadrant, the curves f of x equals 1 over 21, x squared plus 1, and g of x equals e to the 6 minus x minus 1, and to the x-axis. I don't know why and to the x-axis has to be thrown in there if it's the first quadrant. Thank you, but no thank you, ChatGPT. Now, f of x is going to be this little parabola, this very wide parabola, and what we will see when we throw this into the calculator, f of x is going to look like this, give or take. Perfect? No. Accurate enough to get by? And what we will find about e to the 6 minus x minus 1 is it's going to look something like this. Okay, again, perfect? No. Accurate enough? Yeah. So A is asking us to find the area of region R, of course, being the combination of these two guys, this shaded region, if I were to shade that black, which I will not do. All right, so what we need to do is we need to find the area of region R, and we're going to show all of our work. There's 2 things that I have to do before I throw this into my calculator, and I'm going to write it all out. Okay, I'm going to write it all out. What I want to do is, the area under the curve is found by taking the integral, right? So if I were given just one function, if I were told everything happens between 0 and 8, I would take the integral between 0 and 8. Easy peasy. But it's not that easy peasy, because I have 2 curves that run into each other. Okay, so issue number 1 is if I wanted to find this area, I'm splitting this into two parts. And this is how I'm going to handle all three of these problems. The intersection of the blue and the red here, I'm going to call A for now. Okay, for now. Now, what's going to happen here is if I wanted to find just the area under this blue curve, I would take the integral from 0 to whatever that a is, and that blue curve is f of x dx. That gives me this information right here, that area. Now, that's not all I want because I also need this chunk right here. That's going to be the integral from a to this guy, which we will call b. Now, everything is being held in the first quadrant, which means the moment it crosses the x-axis is when I'm done. Okay, b is going to be found by finding the 0 of g of x. So once I find a, which will be found by, intersections, and once I find b, that gets me this chunk right here when I integrate it. If I add this chunk and that chunk, I get all of r, and that gets me the answer to a. So what I'm going to do is I'm going to run to my calculator. I need to find a, I need to find b. Once I find those, I'm going to integrate them in my calculator, and I'm going to add those guys up and see what happens. So we're going to do all of this all at once. All right, so let's plug in both of those formulas. I'm going to let f of x be y sub 1, and that was 1 over 21, which I'm going to put in parentheses because I'm paranoid. Okay, x squared, and then plus 1. Okay. Y sub 2 is going to be my g of x. That was e to the x, so second ln, e to the 6 minus x. So let's throw all of that in there, 6 minus x, and then go out of here. And let's minus 1 because that was the other part of it. All right. Let's see what this graph looks like. Okay, so there's the picture that I drew, but a little bit flatter maybe, I guess. So my thing number one is I need to find out what that a was. Okay, what that a was. Now, I do that by finding the intersection of the blue and the red. So I'm going to hit second, calc, intersect. So hit 5. Let's move closer to the intersections. For the first curve, I like to always hang to just to the left of it. Hit enter. For the second curve, just to the right of the intersection, hit enter. Always guess, hit enter again. And we are going to pocket the fact that our intersection is going to be 4.861. We're going to use that number over and over and over again. Okay, so A is 4.861. I still have to find B. Okay, now B is going to be the 0 of the red line. If I want to focus on just one of the lines, what I'm going to do is I'm going to go to y sub 1 and go to the equal sign and hit enter, so that all I see is the red line. So I'm going to find the 0 of the red line here by going to second, trace to calc, 0. Okay, so let's move to the right a bunch of times so I can see my little cursor. Come on, 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 there you are. Let's go to the left of the 0, hit enter. Let's go to the right of the 0, hit enter, and hit enter. And just like that, the 0 is 6. So my two key numbers are going to be 4.861 and 6. So now using that A as 4.861 and that 6 as B, we can do what we set out to do. So y sub 1 is going to be my f of x. Let's focus on that, and so we'll highlight the equal sign for just that. Okay, so let's graph so we can see just the blue line. Hooray, hooray, hooray. Now if I want to integrate this between 0 and 4.861, I'm going to hit second, trace, which takes me to calc, and there's my integral function. So lower limit is 0, hit enter. Upper limit is 4.861, hit enter, and it fills it in for you. And what we get is 6.684. Okay, so we're going to write that out. We're going to when we go back to the main slide area, we'll write all of this stuff out. But this is how you find the first chunk, the blue chunk. Now to find the red chunk, we're going to go back to y equals, pretend that blue doesn't exist by hitting enter on the equal sign, and by hitting enter on the equal sign for red, now we only see red. So if we hit graph, there you have it. We care about the integral between 4.861 and 6, so we're going to do the same exact thing with our new limits. Second, calc, 7, 4.861, enter, to 6, enter, and we get 0.985 when rounded. So we're going to take those two numbers that we just got, 6.684 and 0.985, and we're going to add those guys together, and that's going to give us what we need. All right, so we ended up with two pretty important numbers, okay? That A ended up being 4.861. That B ended up being 6. So rewriting this guy out was 0 to 4.861 f of x dx plus 4.861 to 6 of g of x dx. Okay, this guy gave us 6.684 plus this guy gave us 0.985. And dummy me, I forgot to show this part in the video. I don't know why I did that, but when you add these guys together, I think you don't need my help on how to add things in a TI-84 Plus. If you could do all of this stuff in a TI-84 Plus, I think you're good. So dumb move by me, but you get the idea. That's what we're going to get here if we were going to go back to our TI-84 Plus and add those up. So that's part A. Part A, dunzo funzo. Now, B is asking us to find the volume of the solid formed when the region R is rotated around the x-axis. So you spin this around, you're going to get some weird looking, I don't know, like the top of a hat thing. I can't draw these, so I'm not even going to try. But what we're going to do is we're going to use the same idea. Generally speaking, when you want to rotate a line around the x-axis to make a solid, the general formula for that is basically you take, and this is any line, so I'm not going to use f and g, I'll use r. So you would do pi r, or pi times r of x dx, and you're going to use your limits. Now what I'm going to do is I'm going to set this up the same exact way, using these two guys being added to each other, but what I'm going to do is I'm going to square the functions, I forgot to say that over here, square the functions and attach pi to it, okay? So I'm going to write out from 0 to what I know now is 4.861. I'm going to put pi in front of it. I'm going to put f of x squared dx. And then I'm going to add from 4.861 to 6 pi g of x squared dx. So I'm going to run back to my calculator, I'm going to do all that fun stuff, and I'm going to see what happens. All right, so unfortunately going back and forth and doing all this stuff makes everything go away in my calculator, but no big deal. According to what I wrote out, let's do this. Let's make believe that I already have this stuff written there. So the original functions were, I believe I had it as 1 in parentheses, 1 divided by 21, and then you have x squared plus 1, and then the other one was e to the 6 minus x, right? Yeah. And then minus 1. Okay, so the reason why I'm rewriting it out like its original form is I want to show you how we can manipulate it so that it's not so bad and I don't have to clear everything and rewrite everything. So if I wanted to make these pi functions squared, I'm going to go to second, insert. I'm going to hit pi. So here's my pi. No. Didn't I do that? Second, insert, hold on, let me go back, let me delete it. I must have done something stupid. Second, delete, which makes me insert. I'm going to hit oh, I know what I did. Second arrow, which is pi, and I'm going to add another parentheses there. I'm going to go all the way over here and close the parentheses and then make that squared. Okay, so now it's exactly what I want it to be. So without me making any typos, let's try that again. Second, insert, second, caret, puts the pi there, parentheses, go all the way to the right, close it, square it. And now I'm going to do exactly what I just did before. Okay, so let's hit the graph, see what they both look like on the same thing. All right, it's definitely new, but that's okay. It's supposed to be. Let's focus on f of x first by eliminating, or not eliminating, but just, silencing the red. So now if I hit graph, I only see that. And we're going to integrate between 0 and that 4.861 number. So second, calc, integral, which is 7, lower limit is 0, upper limit is 4.861. And with that, we end up getting the number 38.594. So let's hold on to that, 48.594. The second one, let's go to y equals. Let's highlight u so I don't see you anymore. Let's highlight u so I do see you now. Let's hit graph to make sure there she is. Let's integrate that by hitting second, trace, which takes me to calc. Go to 7. I care about all the stuff between that 4.861 and 6. And it gives me a value there of 3.9907, which is 3.991. Now, what I forgot to do last time is let's add those guys up. Okay, 38.594 plus 3.991, enter, and you get 42.585. All right, so let's go back and write that out. Okay, so U ended up being that 38.594. U ended up being 3.991. We added them together and got 42.585. All right, so that is how you do B. Now C is extremely similar to B. C is saying instead of rotating it around the x-axis, rotate it around the line y equals -2, which is this line way down here. This requires the washer method. And generally speaking, what you do with the washer method is you would integrate, right, and I'll write it down here, you would integrate from A to B, you would still do whatever function that you have, right? You would still have pi out there. But then what you would do is you would take whatever your curve is, minus whatever number, okay, whatever number that y equals is, and then square it dx. So what that's going to look like here, is I'm going to have an integral from 0 to 4.861 of pi f of x minus -2 or plus 2 dx. Okay, and I'm going to add that to the integral from 4.861 to 6 of pi g of x minus -2 or plus 2 dx. Squared, squared. Can't forget to square those parentheses. That changes everything. Okay, so let's run to our calculator, see what happens. Okay, so coming back here and going back to the y equals that we had before, when we manipulated them, we're adding 2 inside each of the parentheses. So I'm not going to write out +1 plus 2 because that's a waste of time. Let's just make u +3. And instead of down here doing the same thing and writing out -1 plus 2, let's just make that +1 because -1 plus 2 is +1. So let's focus on just the blue. We're going to do the same exact steps that we did before. Focus on just the blue. Second, trace takes us to calc. 7 is going to take us to our integral. I don't see anything, but who cares? I don't need to see anything. If I'm adding 2 squared, which is plus 4, it just moves everything up. So I'm going to plus, or my lower limit is 0. My upper limit is that same 4.861. If that number isn't burned in your memory after watching these videos, shame on you. We end up by doing that getting 175.675. Okay, so that's the first guy. The second guy, let's go back here. Let's hit enter so I don't see it anymore. Let's hit enter so I do see U. There U is. And let's do the same thing. Second, trace 7. I care about 4.861 to 6. That value is going to be 30.677. Now let's add those two numbers up. Okay, 175.674 plus 675. Why did I say 4? Plus 30.677. And we get 206.352. Let's go back and circle that. Doo-doo-doot, says the computer. Let's go back, circle that, and be done. Thank God. All right, so this top guy ended up being 175.675. This guy ended up being 30.677. And when we added them together, we got 206.352. Yum, 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 yummy, yum, yum. I don't need that over there. That's in the way. All right, that was intense. So hopefully you enjoyed it, because I certainly did. All right, more to come. Free response question number 3. No calculator. That's fine. We don't need one. Calculators are for suckers. Anyway, this figure below right here shows the velocity v, also known as dSdt, also known as f of t, all these names, of a body moving along a coordinate line in meters per second. Answer the following questions based on the graph. Well, let me reiterate that this graph is velocity, not position, which is usually given to you as s of t. This is the velocity function. So anything that's positive is u moving forward. Anything that's negative is u moving backwards. So at this moment right here, you're moving forward at 1 meters per second, 1 meter per second. Now you're moving forward at 3 meters per second. Now you're moving forward at 3.5 meters per second. Now here you're moving backwards at 3 meters per second. So when does the body reverse direction? Well, the body reverses direction at any time where it crosses the x-axis. Anytime there's a sign change is when it reverses direction. So to answer part A, there's a sign change at 4 and a sign change at 8. So A is going to be t equals 4 seconds and t equals 8 seconds. And that is because the body reverses direction anytime there is a sign change. And that occurs anytime there is a sign change. And that occurs when, you can see that I'm not really good at all multitasking. That occurs whenever you cross the x-axis. Now part B is asking, at what time or times is the body moving at a constant speed? Well, again, velocity is basically positive or negative speed. So when do we have a horizontal line for velocity? Well, that happens at once. By the way, the devil is going to tell you, oh, that's constant, isn't it? That's constant, isn't it? No, we're technically speeding up. The velocity at this moment from here to here is increasing. That's not constant. You're going from 1 meter per second to 2 meters per second to 3 meters per second, back down to 2 meters per second, blah, blah, blah. The only time where you're going to have a constant speed is in between 6 and 7. So the body is moving at a constant speed when t is in between 6 and 7 seconds. And that again is because the velocity is a horizontal line. So at this moment, we're going backwards at 3 meters per second for a whole second there. And that's it. That's the only time that happens. That only time. So that's how you answer B. All right, so I switched over to the next slide, and the question that's being asked is the same thing, same exact picture, just, cleaned everything up here. What is the body's maximum speed? Provide the explanation for your answer. Well, the body's maximum speed is actually 2 times here. Now, velocity can be positive or negative, right? A positive velocity means you're moving forward. A negative velocity means you're moving backwards. Speed is the absolute value of velocity. So this is going to happen twice. So for C, you have at t equals 2, and when t is in between, what is that, 6 and 7? We did that before. The speed is 3 meters per second. Okay, and again, the explanation for that is because speed is the absolute value of velocity. Now, if it asks you the question, what is the maximum velocity? The answer would be 3. What is the minimum velocity? The answer would be -3. But that's not what it's asking. It's asking for speed, which is the absolute value of velocity. Now, this last one has the potential for a lot of confusion. Okay, so let's try to understand one more time that this is the velocity function and what velocity means. The question being asked is, during what time intervals is the body slowing down? Provide an explanation for your answer. This is velocity. Okay, anything that's above the x-axis means you're moving forward. Not increasing, not decreasing. It means you're moving forward. I am moving forward here, 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 and here. I'm moving forward here. Okay, anything under the x-axis means I'm moving backwards. So what this is telling me is I'm accelerating, moving forward. At this moment right here, I am slowing. So pretend that this is a car. I'm driving my car faster, moving forward, moving forward, moving forward. Now I'm still moving forward, slowing down until this moment right here. Okay. Now I'm slowing down, moving forward. This is a slow down, which is a decrease in velocity. So interval number 1, and we'll write it out this way because we haven't written it out this way yet. Interval number 1 is going to be when t is between 2 and 4. Okay, now the devil is going to tell you, well, why did you stop at 4? Shouldn't you keep going? No, because now what we're doing, right at this moment right here, by going underneath the x-axis and making our digits larger, we are actually increasing in speed, moving backwards. At this moment, we're stopped. Now we're moving backwards, moving faster. This is not slowing down. This is speeding up. This is staying at the same speed. And here, what we're doing is we're slowing down while going backwards. So the other interval is going to be between 7 and 8 because we're slowing down while going backwards. So the explanation for this is, for the first one, it's positive, the velocity is positive but decreasing. Okay, so velocity is positive and decreasing. And for this next one, we could say that the velocity is negative and increasing towards 0. Now what that means, one more time, what that means, one more time, is since we're moving backwards, okay, we're going from moving backwards at 3 meters per second to 2 meters per second to 1 meter per second to stop. Okay, so the velocity is negative and increasing towards 0, which means you are slowing down while going backwards. So, kind of a bizarre question. Again, not a ton of math, hardly any math at all, really. It's just understanding what graphs look like and comparing velocity to position to acceleration and all that stuff. But yeah, that's free response question number 3. Pretty short and sweet. All right, free response question number 4, no calculator. Well, we don't need one. Find the equation of the line tangent to f of x at x equals 2 in point slope form. All right, so one at a time. The tangent line at any point, we have ourselves a line. I don't know exactly what happens at x equals 2. This could be completely off, but let's just make believe it happens here, right? If that is where x equals 2, the tangent line is some line that basically creates that slope at that moment. It's a snapshot of the slope at that moment. What we want is the equation of that line. So this is what we're going to do. We're going to take the derivative of this, okay, and then we're going to plug in what happens at 2, and that's going to give us our slope, okay? Now, once we have our slope, we know that x equals 2. In order to use point slope form, which is what they want, we need a slope and we need a point. This will give us our slope. We have half a point. So the other point is to take f of 2, and that will give us our y value. Once we have our slope, and we find out what happens at f of 2, and by the way, yes, f of 2, not f prime of 2. F prime of 2 gives a slope, f of 2 gives us a point. Once we have that, we write out our point slope form, which is y minus y sub 1 equals m times the quantity x minus x sub 1. All right? So those are our 3 steps. So let's take the derivative, plug in 2, and that will give us our slope. So this is just power rule, nothing. So f prime of x is going to be the derivative of x cubed, which is 3x squared, minus the derivative of 48x, which is minus 48x, plus the derivative of 3, which is nothing. F prime of 2 is going to be 3 times 2 squared minus 48, which is going to be 3 times 4 minus 48, which is going to be 12 minus 48, which is going to be, holy crap, negative 36. So our slope is negative 36. Okay, so that's part 1. Now so point slope form, we found our slope. Now I need to find our point. Our point, we have half of it, x equals 2. I need the y value, so let's plug in 2 into this original problem, So f of 2 is going to be 2 to the 3rd power minus 48 times 2 plus 3. So that's 8 minus 96 plus 3. And 8 minus 96 is negative 88. Negative 88 plus 3 is negative 91. No, it's not. Negative 85. What was I thinking? Negative 85. All right. So that's our point. So we have y minus y sub 1 equals m times the quantity x minus x sub 1. We have a slope at negative 36. We have a point at 2, negative 85. So if I were to label you x sub 1, y sub 1, we can put everything together. Y minus negative 85 equals negative 36, x minus 2. Cleaning this up is going to be y plus 85 equals negative 36 times the quantity x minus 2. Yuck, gross, no thank you. Now B here is asking us to determine all critical points of f of x. So let's do things one sentence at a time because there's 3 things that this guy is going to ask us to do. So B is asking us to determine all critical points. Let's get rid of this over here. I don't need that. I'm going to need the space, and I'm going to probably want a new slide for C. All right, critical points exist when your derivative equals 0. So I have my derivative. I found that out. So let's set that equal to 0. 0 is equal to 3x squared minus 48. We can factor out a 3, and that leaves us with x squared minus 16. Okay, now let me move that up here. 0 equals 3 times, oh wait a minute, I know what that is. That's difference of squares. Oh, that's much easier. So my critical points are going to exist when x is positive 4 and when x is negative 4 because those are the numbers that make those factors 0. 3, who cares? So those are my critical points. Identify the intervals where f of x is increasing and decreasing. Well, this is going to be pretty easy. The graph here is a positive leading coefficient cubic, which means it's going to look like this, right? I call this the Drake cubic because it starts from the bottom and now it's here. I know Drake's kind of a sensitive topic lately, but you know what? I'm leaving it. Anyway, if I write out a sine graph, knowing very well that my critical points are 4 and negative 4, okay, I'm going to have a sine graph at negative 4 here and positive 4 here. And this is the sine graph for the derivative, which is going to be f prime. Now, what the critical points give us is where the slope equals 0. When I say, let's take the derivative and set it equal to 0, that's me finding when this slope is 0. So you are a critical point and you exist at negative 4. You are a critical point and you exist at positive 4. Which means if your critical points, anything that is not a critical point is either going to be increasing or decreasing. So here you are increasing, you hit a maximum, then here you are decreasing, you hit a minimum, and here you are increasing forever and ever and ever. So the intervals where f of x is increasing is going to be 2 of them. Okay, the increase exists from negative infinity to negative 4 union 4 to infinity. That's where we're increasing. My decreasing is only once, and that happens from negative 4 to 4. So still not done the problem yet, because now I need to classify all local extrema. So what I'm going to do is not only am I going to just say, oh, okay, well, local extrema is we have a maximum at negative 4 and a minimum at 4. I'm going to find out what those points are. So my maximum exists at negative 4. So that means we're going to plug in negative 4 into the original function to get us the exact point where this happens. So that's going to happen at negative 4 cubed minus 48 times negative 4 plus 3. So negative 4 cubed is negative 64. Minus 48 times negative 4 is going to be 192 plus 3. So 192 plus 3 is 195. 195 minus 64 is going to be 131. Okay, so that tells us that we have a maximum at negative 4, 131. And that, let's be specific, that is a local max. You know what they call it? They prefer relative in calculus. So you have a relative maximum at that point right there. Okay, circling all of the answers that I came up with so far. All right, so I have a relative maximum at negative 4, 131. To find my minimum, I'm going to do the same thing but plug in regular 4. So f of regular 4 is going to be regular 4 cubed minus 48 times 4 plus 3. So that's 64 minus 192 plus 3, which ends up being negative 125. So that's my relative minimum exists at the point 4, negative 125. All right, so we conquered all the beasts of Part B. Okay, Part B, determine the critical points. There you is. Identify the intervals where f of x is increasing or decreasing. There you is. Classify the local extrema, also known as relative extrema. There you is. There you is. There you all is. All right, now Part C, and we're going to move to a different slide in this, is going to ask us to find the area enclosed by f of x in this brand new g of x. Okay, so we're going to have two functions. You have this cubic, you have this line, and they're going to intersect somewhere, but that's great. However, what's nice is they're giving us two lines. These are going to be our limits of integration. To find the area of a function, you use integration. Now, if you're going to do two functions, what you're going to do is you're going to take the integral, lower limit, upper limit. You're going to do f of x minus g of x dx. Now, here's the thing. I don't know which one's on top. I don't know which one's on the bottom. I mean, according to this picture, it looks like the linear guy is on top, so whatever, who cares? If I get a negative answer, I'm just going to take the absolute value of it, make it positive, and I'm not going to lose sleep. So the integral that I'm going to write out is going to be the integral from regular 1 to positive 2 of f of x, so x cubed minus 48x plus 3 minus g of x, which is going to be minus 55x minus 3. Close it, dx. So that turns into the integral from 1 to 2 of x cubed. Negative 48 minus 55x is going to be negative 103x. 3 plus 3 is 6. Okay, now I can integrate. The integral of x to the third, and let's move that up here, is going to be 1/4 x to the fourth. The integral of negative 1 over 3x is negative 1 over 3 halves x squared. And the integral of 6 is 6x. And my limits are 1 and 2. So we're going to have gross math here that we're going to have to deal with. It's unfortunate, but it is what it is. Okay, so I have, let me make sure I have enough space. I don't know if I did a good job with that. 1/4, 2 to the fourth, minus 103 halves, 2 squared, plus 6 times 2, minus 1/4 times 1 to the fourth, minus 103 halves, minus, let me make that minus sign much clearer than it is, 1 squared plus 6 times 1. Okay, so 1/4 times 16, it's a close one, minus 103 over 2 times 4 plus 12 minus 1/4 minus 103 over 2 plus 6. So you become 4. You become minus 206 plus 12. If we combine these into one big fraction, I don't want to do it. I don't want to do it at all. Let's just do decimals. 0.25 minus, what would that be? 51 and a half. plus 6. All right, that first bracket, negative 208 plus 16 is negative 190. You become negative 45.25. Double negative becomes positive. So now we're looking at negative 144.75. So I did it backwards. No big deal. Our final answer is just make this guy positive. And by making it positive, we end up with 144.75. Yuck, yuckity, yuck, yuck, yuck. But that's it, and that ends free response question numero tres. No, number 4. Oh, yeah, I don't want to go backwards. A couple more to go, and then we're done this thing. All right, free response question number 5. We're almost home, kids. No calculator, that's all right. An open box is to be constructed from a 10-inch by 16-inch piece of cardboard. This is done by cutting out squares of side lengths x from each of the 4 corners and folding up the sides to form a box. Let's draw a picture. So we have ourselves a rectangle. Yeah. And we're going to cut out 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 squares out of each side, and each square is going to be x in length, x inches long in length. We'll call you 16, we'll call you 10. Now, there's my picture. You're welcome. Explain any domain restrictions for x, the length of the square cut from each corner. How do these restrictions ensure a valid box is formed? Well, basically what's going to happen is you're going to cut out these x's, and the restrictions are basically saying what x values am I allowed to use, right? Like I can't just say, oh no, I'm going to cut 15-inch, I'm going to cut 20-inch x's out of each corner because I don't even have that much information. So what is the smallest possible value that I can use? Well, for A here, the smallest possible value that I could use is 0.00000001. I can cut a tiny, itty-bitty square and still have enough availability to fold it up and make myself a box with no top. So 0 is my smallest. Now my largest is found by taking the shorter side and halving it, but not equaling that. So if I wanted to, I can cut out sides or squares that are 4.99 and 4.99 and still have just a little bit of space to fold it up and make it the tallest, skinniest box known to man. So my domain restrictions are going to be x has to be in between 0 and 5. And the reasoning why is you must take less than half of the shorter side. Now, why is that? Well, because when you do cut out these squares and fold them up along these invisible lines, you're going to end up, excuse me, I just get so choked up about these problems, I get excited. You end up with a box, okay? The height of that box is x because you're folding it up. You're folding it up. The height of the box is x. The length of the box is found by taking away 2 of these x's. So 16 minus 2x, and the depth, or whatever you want to call it, the width of that box is going to be doing the same thing, 10 minus 2x. We just don't know what x is. Determine the value of x that maximizes the volume of the box. Show all necessary calculations. Well, the way you use it, and by the way, this process is called optimization. The way you maximize or minimize an object is you take the function that can be created. Take the function of what you're trying to find. In this case, we're trying to find the volume. You are going to differentiate that. Take the derivative and find all critical points. You're going to use the critical points and also these points and find out which points are going to give me the largest value. So first things first, I need to come up with a formula for volume. Well, volume of a rectangle is length times width times height. So I'm going to do V equals x times 10 minus 2x times 16 minus 2x. This is just my volume formula. Okay, distribute the x. V is going to equal 10x minus 2x squared times the quantity 16 minus 2x. Okay, FOIL this guy out, FOIL that guy out. So let's be consistent with my colors. 10x times 16 is 160x, so V equals 160 regular x. 10x times negative 2x is negative 20x squared. Negative 2x squared times 16 is negative 32x squared. And negative 2x squared times negative 2x is going to be positive 4x to the third. Let's write this out in standard form and also combine like terms. So 4x to the third will go first. Okay, these guys combine to make negative 52x squared, and then plus 160x is lingering. Now what I need to do is take the derivative and set it equal to 0. So the derivative of this guy is v prime equals the derivative of 4x cubed is 12x squared. The derivative of negative 52x squared is negative 104x. And then the x just drops away. Oh, 160. See, no one will ever know. Let's move that up here. Set it equal to 0. Now, what I'm going to have to do is I'm going to have to factor that, and I should be able to factor out not a 12, a 4. I can factor a 4 out of that. When I factor a 4, it's still going to leave us with 3x squared minus 26x plus 40. So to find the critical points, we're going to have to continue factoring. This isn't going to get me anywhere. And looking at that, I don't think that's quadratic formula. Nope, it's going to be 3x minus 20 and x minus 2. Right, 3x squared minus 6 minus 20. Yep, so that'll do just fine. That'll do just fine. Now the critical points that I'll get here will be found by taking 3x minus 20, setting it equal to 0, adding 20, and dividing 3, and x is going to equal 20 over 3. Okay? Over here we get x equals 2. Easy peasy. Now at this stage you should be yelling at your phone or computer screen or however you're watching this and say, 20 over 3 is 6.6 repeating, isn't it? Which lands outside of the domain that you're allowed to use, which means you are not an option. You're not. So this is what I have to do. I need to take my endpoints here, and I need to take this critical point here, plug it into the original problem, and see which one of these maximizes the volume. And by doing this, it'll allow me to answer C at the same exact time. So we're going to plug in 0, we're going to plug in 5, and we're going to plug in 2 into this original volume problem. So now I can change colors. Now I feel comfortable changing colors. So V of 0 is going to be, I already know it's going to happen, 0. I'm not going to waste any time doing a whole lot of math. All right. V of 5 is going to be V, so that would be 5 times 10 minus 2 times 5, which is 10, times, you know what, who cares, because 10 minus 10 is 0, so you're going to be 0 anyway. Now, we knew this. We knew by plugging in 0, that's me basically saying, I cut out nothing. Now, I know 0 is not allowed, so if we just make believe that this is 0.000000001, I'm going to basically get 0.000000001, and that's not going to be a big volume. Similarly, I know I can't cut out x's of 5, but I can cut out x's of 4.555555555, or 4.999999999, which would be a lot better. And if I plug in 5 and get 0, then plugging in 4.99999999999 is also going to give me 0 or something awfully close to it. So the only one here that's going to make sense is 2. So x equals 2. And how am I supposed to answer this? Determine the value of x that maximizes the volume. So x equals 2 is going to be my guy. So for part C, let's find out why. V of 2 is going to equal, let's use that formula right there, it just seems easier for me, 2 times 10 minus 2 times 2, which is 4, 16 minus 2 times 2, which is 4. That's going to get me 2 times 6 times 12, which is 12 times 12, which is 144. So the answer to part C is going to be 144 inches cubed. All right, so x is 2 inches for B. That's the value that maximizes it. And the maximum volume that we're going to get is 144 inches cubed. So this is the standard box with no top optimization problem. You know, I've been teaching calculus for a few years. I use this problem every year. It's very typical, very standard. Will you definitely see it in an AP Calculus problem or test or whatever? I don't know. But I like it, and so I did it. And that, ladies and gentlemen, is question number 5 for the free response problems. On to the 6, and then we're done. All right, my brothers and sisters, we're finally at the end. Problem 6. Given the functions f of x equals sine 2x and g of x equals cos squared 2x, answer the following questions. All right, calculate the instantaneous rate of change of g at x equals pi over 4. Show your steps. Instantaneous rate of change means the derivative at a point. So what I need to do is find the derivative of g, and then once I do, plug in pi over 4. Now g is cos squared 2x. I'm going to rewrite it like this because it helps me understand it better, because I'm going to be applying chain rule to this guy. So we have cos 2x squared. Now chain rule says that we take the derivative of the outside, which means we drop the 2 in front, right? Make that an invisible 1, which we'll clean up in a bit. Obviously, we have got a lot going on here. Keep the inside stuff, which is cos 2x, and then multiply everything by the derivative of the inside stuff, which, fun fact, is going to be chain rule yet again. So the derivative of the inside stuff is going to be negative sine, because we're taking the derivative of cosine. Keep 2x, but then multiply everything by the derivative of 2x, which is 2. All right, so what we end up with is g prime is going to equal, we can throw that negative out there, we can keep that 2 times 2, which is 4 out there, and then we have, since that's the invisible 1, cos 2x sine 2x. Now, I need to plug in pi over 4. So g prime of pi over 4 is going to be negative 4 cosine. Now, 2 times pi over 4 is pi over 2, okay? And sine 2 times pi over 4 is also pi over 2. Cosine of pi over 2 is the same as cosine of 90 degrees, which is a big fat nothing. And sine of pi over 2 is going to be, well, you know, who cares, because all of this is just going to be 0. So the instantaneous rate of change at x or pi over 4 is 0, which means the tangent line is a flat horizontal line. Fun, 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 fun in the sun. Fun, fun, fun in the sun. Okay? Show your steps. I did. Let's go to B. Find the second derivative of f of x, denoted as f double prime of x. Show your steps. Well, f of x is sine 2x. The derivative with respect to x is chain rule. Take the derivative of the outside, which is cosine. Keep the inside, which is 2x, but then multiply everything by the derivative of the inside, which is just 2. So f prime of x can be cleaned up and turned into 2 cos 2x. F double prime is the derivative of what we just came up with. So 2 still lives there. Cosine is going to become negative sine. Take the derivative of the outside, keep 2x, which is the inside, and then multiply everything by the derivative of the inside, which is 2. So very similar to what we saw over here. Very, very, very similar. But this cleans up to f double prime of x equals negative 2 times 2, so negative 4 sine 2x. Okay? Show your steps. I did. I just did. Now onto the hammer. Okay? Calculate the area under the curve of f of x over g of x. So before we do anything, Okay, let's find out what f of x over g of x actually is, and we'll do that over here. F of x over g of x is going to be sine 2x over cos squared 2x. Now that 2x is gold because that tells me we can simplify stuff. What I could do is I could rewrite that out as sine 2x over cos 2x. And then over here, I basically have 1 over cos 2x. That's what sine squared 2x means. I mean, I wrote it back in part A that it's the same thing as cos 2x, all of it squared. Now u becomes sine over cosine, which is tangent, 2x. And u become 1 over cosine 2x, which is secant 2x. So what it's asking me to do is calculate the area under that curve. Okay, so to calculate the area under the curve, that is going to be an integral. And we're going to integrate it from 0 to pi over 6. Okay, show your steps. So I'm going to integrate from 0 to pi over 6 tan 2x secant 2x. Now, there's a lot of ways you can handle this, okay? I just so happen to have it memorized that the integral of tan x, okay, and this is just a fun fact I'll write off to the side, the integral of tan, and we'll actually do this, tan u secant u du happens to be secant u, plus c technically, but whatever. Okay, that's a little rule. So I know all of this will eventually become secant. However, that 2x is not x. I can't just apply that rule. So what I have to do is I have to do u substitution. So I'm going to let u equal 2x. Now this isn't that bad because then you do the du dx, the derivative with respect to x, and that's just going to be 2. And I need to find a way to replace that dx, so I'm going to multiply dx divided by 2, and then dx is going to end up being du over 2. So simplifying this a little bit, I have the integral, okay, as x goes to 0 and x goes to pi over 6. I have du over 2, so tan, first off, 2x is now u, so tan u, secant u, du over 2. Basically, pull the 1/2 out. So to pull the 1/2 out, my limits are still x is going to 0, x is going to pi over 6, and then I have tan u secant u du. And according to what I just wrote right over there, that is going to become secant u, where my x limits are still pi over 6 and 0. Let's substitute what that actually is, and let's kill two birds with one stone. I could bring that 2 back out, that 1 over 2 back out. Okay, secant is cosine, and u I called 2x. So I'm going to write it out like that. Okay, so what I do now is I'm going to plug in pi over 6, so 1 over 2 cos, 2 times pi over 6 is pi over 3, and I'm going to subtract me plugging in 0. 1 over 2 cos, 2 times 0 is 0, so cos 0. Cosine of pi over 3 is 1/2, so you're 1 over 1/2, and cosine of 0 is 1, so minus 1 over, oh, did I forget something? I did. 2 times 1/2, oh boy. So 1 over 2 times 1/2, that would change things. Over 1 over 2 times cosine of 0, which is 1. So I get, and hopefully this doesn't get cut off when I make the video, it shouldn't, 1 over half of 1, or half of 2, which is 1, minus 1 over 2 times 1, which is 1/2. And when all is said and done, I get 1/2. That, ladies and gentlemen, is it. That is the Math Teacher GOAT Ultimate AP Calculus exam, beginning to end, soup to nuts. I hope you enjoyed it. Share this with all of your calculus friends. Thank you for watching. I love you. Bye.